short video will just be about how to write even and odd numbers algebraically and in general. And think about it. Well, what are even numbers? Even numbers are things like 2 or 6 or 10 or 12 or 100. Whatever. So there's some examples of even numbers. So here's my question to you. Try and come up with a way to explain to somebody, let's say they don't know English and they can really only understand a diagram. Think if you can come up with a way of explaining to that person what it means for these numbers, or some of these numbers at least, to be even. What's the commonality here that you could show in a diagram? So try that. Okay, so I think everybody knows, well, even numbers, what makes them even is they have a factor of 2. They're divisible by 2. So I want to focus on these 3 here because they're of a reasonable size to draw diagrams for. 2 is a little too small to really see what's happening, and 100 is a little too big, but we'll talk about that in a second. Well, how would I show somebody that 6 is even? Well, it means that I can group 6 things in 3 groups of 2, like this. So I can draw a little rectangle that's 2 by 3. And in some sense, it's not really important how many groups I make here. I made 3 groups of 2. All that's important is I can make groups of 2 out of it. There happens to be 3 of them. And so we can see here that 6 is 2 times 3. And again, the important bit is this 2. It's even, it's divisible by 2. We can write it as 2 times some other number. In this case, it happens to be 3. For 10, well, we can do the same thing. There are 10 dots, and you can see I grouped them in groups of 2, and there happens to be 5 groups. And 10 is, of course, 2 times 5. And again, the important bit is that I can make groups of 2 out of them. And 12, of course, well, same idea. I think you guys got the hang of it now. It's 2 by 6. So 12 equals 2 times 6. And again, the important bit is the 2. And now let's talk about 100. So again, I can't really draw 100 dots. Well, I could, but it'd be kind of a waste of time. But what I can do is I can just put some dots here, just to say, oh, the pattern continues. I'm just grouping a bunch of dots in groups of 2. And I'll just write down how many groups there are. So the groups are of size 2, just like before. And now there are, I'll just tell people, there's 50 groups of 2. And 100 is, of course, 2 times 50. Again, the 2 being the important bit. And in general, because that's the important bit, what do all even numbers have in common? Even numbers can be written as 2 times some other integer. So, an integer, oh, let me do this in black. Sorry, guys, an integer, n is even if and only if you can write n as 2 times some other integer. I'm going to call it k, and then I'll tell you what k is. For some k, which is indeed another integer. Or maybe I could express it in terms of an existential quantifier directly. So an integer n is even if and only if there exists a k in the integers such that n equals 2 times k. So that's another way of writing it. If there exists a k such that n equals 2 times k. So that's what I mean by an even integer. And we're going to use this all of the time. So this is something you should remember. This is very important. Even means 2 times another integer. Odd, very similar. I won't do such a long process with odd. Let me just write down 3 examples. Let's do 5, 11, and maybe 101, and then we'll talk about the general case. Well, the thing is, odd numbers cannot be evenly divided into groups of 2. There will always be 1 left over. So if I wanted to draw 5, I'll try to put them in groups of 2, and I always get this 1 left over. There's 5. So I have this kind of, I try to put them in groups of 2, so I have groups of 2, and here I have 2 groups of 2, but I have this extra 1 plus 1 left over. So 5 is 2 groups of 2 plus your extra 1 that you can't group. You're unable to group. So again, this 2 is the important bit, the size of your group. Let's do it again for 11. So let's draw 11 dots. Try and group them in 2s. There's 10. And the 11th, we can't. So the best we can do is we can say we have groups of 2, and we have 5 groups of them, but we still have this plus 1, this extra 1, left. So 11 is 2 groups of 5 plus 1. Again, the important bit is the 2. And 101, again, well, I'm not going to draw 101 dots, but I'm going to put some ellipses there, dot, 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 just to indicate that there are more groups between there. And I'll have this extra 1. And I'll tell people that, of course, we have groups of size 2, and there are 50 groups with this 1 left over. And of course, 101 is our 2 groups of 50, so we could group 100 of those dots. Again, the 2 is the important bit. The 50 really isn't. So we have that 1 left over, unable to be grouped. And so a general odd integer is kind of the same thing. You can think of it as an even integer plus 1 more. So let's write that down. An integer n is odd if and only if. And another way of expressing it, maybe you don't want to say if and only if, you could write if with 2 f's, or you could write exactly when, or is necessary, or and sufficient. But I'll write if and only if an integer n is odd, if and only if, and let me write it in terms of the existential quantifier here a little more explicitly. So there exists, or there is, some integer k such that we can write n as 2 times k plus 1. And again, this is going to be really important. We will bring up even and odd integers all the time, and you'll have to know that that's how to write them in general algebraically. So remember that. You need to be able to write n equals 2k for an even integer. And remember to tell people what k is. K is some other integer. A good rule here is whenever you introduce a variable or a symbol, tell people what it means. If you introduce this variable k, tell people what it is. Well, k is just some integer. Always do that. Whenever you're introducing a variable, tell people what it is. And that is how to write even and odd numbers algebraically in general. And in the next few videos, we are going to use these a whole bunch so we can learn and practice our various proof techniques so far.